Welcome to Distinction Learning Platform. And in this video, we are going to solve an examination question in mathematics, focusing on probability. Okay, great. So before I can go any further, I'll start by defining what probability is. So probability, by definition, this is the likelihood of an event to occur or not to occur. Probability is the likelihood of an event to occur or not to occur. So what does it mean when we say the likelihood of an event to occur or not to occur? So generally speaking, it means you are not so sure if something is going to happen or not to happen. Okay? Yes. So probability by definition is the likelihood of an event to occur, okay, to occur, rather happen, or not to occur. Yes, so under probability, there are two important things, okay, which we're supposed to know. The first one is that the probability of an event to occur is always what? 1. The probability for an event to occur is always 1. And the probability of an event not to occur is 0. Meaning, you are sure to say something is going to happen. The probability is always 1. Okay? Similarly, you are sure to say something is not going to occur or rather happen. The probability is always 0. So the probability of something to, to occur, okay, the probability of something to occur, we are saying this is what? 1. And the probability of something not to occur, the answer is always what? 0. Therefore, from these two important concepts, we can be able to come up with the formula, which is the probability of something to occur plus the probability of something not to occur. The answer should always be 1. Why 1? Because we know to say the probability of something to occur is what? 1 plus the probability of something not to occur is 0. If we were to add 1 plus 0, we'll get 1, like that. This is very, an important formula, and basically we normally use this formula in paper 1, okay, mathematics paper 1, both for grade 12s as well as GCE. Great. Then from here there is also another important formula, okay. This formula is mostly applicable when you are solving examination questions in mathematics paper 2, okay. This one we can use it both either in paper 1 as well as paper 2, depending with the question. And the formula is as follows. The probability is equal to all favorable, okay, all favorable outcomes divided by what? All possible what? Outcomes. Okay, so a favorable outcome basically is what you are looking for. That is the interest, okay? And all possible outcomes basically is just the total number. The total number I would say, for example, if in a box, this is a box, okay? I would say 2 blue marbles, as well as say 3 yellow marbles, okay. Then the question is saying 1 marble is picked at random from the box, and what is the probability for randomly selecting a blue marble? So my favorable outcome or my interest is a blue marble. So I would represent it like this. Okay, B means blue. P, that is probability, is nothing but equal to. My interest is what? My favorable outcome. The total number of blue marbles is basically 2 out of. All possible outcomes is just the total number, okay, which is 2 plus 3, and it is what? 5, like that. Okay? That's how we use this formula. Great. Now, back to our question. Okay? Which is saying a box contains 6 white circuit breakers and 4 black circuit breakers, all identical in appearance. A circuit breaker is selected at random from the box and not replaced. A second circuit breaker is then selected. Find the probability that both circuit breakers selected are white. Then this one is of different colors. Okay. So when you are answering questions in paper 2, it is very advisable for one to create, or rather make, a tree diagram, because when you make a tree diagram, it is very easy for you to tackle, or rather answer, the given question. Okay, so always rather make sure you create a tree diagram. Okay, so now here I'm going to come up with my tree diagram. Okay, so my tree diagram now will have, I'll look at the question. So the question has got 6 white circuit and 4 black circuit. So in terms of the branch, this one, there will be what? How many? 2. If, say, suppose I'd maybe another a circuit, okay, say maybe 2 yellow circuit breakers, I would have had 3 branches, but in this case it's just 2. Why 2? Because I just have I have white and black. So this branch, okay, according to the question, it is saying a circuit breaker is selected at random from the box and not replaced. Okay, so a circuit breaker. So they were selecting how many? 1. So one trial. Okay, we have white, black, and another one here we have white, black. So basically, when they were selecting these circuits, they would perform one event after the other. Meaning, in a box, there are this person, when he's selecting, is expected to be picking, or rather selecting, a circuit at random, meaning the person doesn't know or doesn't have an idea. So there's a possibility that the person might select a white circuit or a black circuit. Okay, so here I'll use the same formula to say probability is equal to all favorable outcomes over all possible outcomes. So my interest on white, this is white. So I would say the probability for white is nothing but equal to, how many whites? 6 out of all possible outcomes, which is basically the total. So the total here is 6 plus 4, which is a 10, like that. Similarly, I will do the same thing for which one? For black. I will use capital letter B representing black circuit breakers. So for circuit, it was 4 out of, the total number was what? 10, like that. So I'll put for 6, this is 6 out of 10, this is 4 out of what? 10. So in order for you to know or show that you're doing the right thing, or rather the correct thing, if we were to add this plus that, you're supposed to get 1. If you can't get 1 here, it means you are wrong. Okay? If you can't get 1, it means you are wrong. What does it mean? It means that if I were to add 6 out of 10 plus 4 out of 10, okay, since the denominators are the same, I can just add up the what? The numerators. 6 plus 4 is basically 10 out of 10, and this is 1. Okay? Yes. And once I get this one, this implies to say I'm doing the correct thing. Great. How come to here now? When this is probability without what? Replacement. Okay? So if I get, this is white. If I were to, if I get 1, okay, circuit breaker, which is white, from the total number of white circuit breakers, there were 6. I will remain with what? 5. Okay? But since I've selected, okay, and I'm not replacing it, okay, it means I've taken that circuit breaker for good. Hence, what happens to the total? The total will be affected. It will change from 10 to what? To 9. Why 9? Because one circuit breaker is, selected. Great. But what happens to the black, circuit breakers? The black circuit breakers will remain the same, which is just 4. But the total number is affected. Why? Because had selected one white breaker. Hence, it will be 9 like that. Great. So if I were to check here, if I'm doing the right thing, if I add this plus that, I'm supposed to get 1. The denominator is the same. The numerator is 5 plus 4 is 9, 929 is 1. Great. Next, I'll do the same thing. If I want, I would have started with what? 6. I know that here, if I were to get 1, the total number here, which is 10, it should change. Or what you can do, you can start with, black, like I select a black, or rather you select a black, so you remain with what? 3. Out of this total number, it will change from 10 to 9. Why? Because I've selected a black circuit and I haven't replaced it. What happens to white? White here is 6, okay, like that. But the total number will do what? It will change. It will be 9. Why? Because it's a black circuit, breaker or Z selected and not replaced. So basically, this is how you come up with a tree diagram. Great. Okay. Great indeed. So now, let us now answer the questions. Which is, I can look at the outcomes. So the outcome here I have white, I have white, black. Great. I have black, white, white. I have black. So from the outcomes, these should be able, to help me to answer these what? Questions. Great. Okay. Okay, so the first question is saying, find the probability that both circuit breakers selected are white. So the probability for white, both white, like that. I will say the probability for white. I'll check on my outcome where both circuit breakers are white. So in this case, on my outcome, I have white, I have white, blue. So this is the the only outcome which is showing white. So that's how you represent it. If they ask you to say find the probability, that both circuit breakers are white, you represent it like this. And I can now substitute. So for white, I have 6 out of 10. Okay. Then, if you are going across, you multiply probabilities. But if you are going below, you add. If you are going across like white, going across like this, you multiply probabilities. So I'll multiply this by, this is 5 out of 9, okay, like that. So it is advisable to, you know, use a calculator, okay, in case you are there wondering to say how can you, you know, multiply this by that, and which is very simple. So 6 by 5, basically this is you know, 30. 10 by that, this is 90, like that. So as you can see, this is very simple. You can reduce, 0 goes, 0 goes, 3 there is 1, 3 there is basically what? 3. So the answer is 1 over 3. Next, we have to find the probability of different colors. Probability of different colors. You see, okay? So how do you now represent the probability of different colors? So we look at the outcomes as usual. We check. We have white, white. This is semi, so this doesn't qualify. We have white, you know, black. So this is, you know, 2 different colors, like that. This qualifies. We have black and white. This is also qualifies because they have 2 different colors. Okay. Here, DB, both are, you know, black. So this doesn't qualify. So our main interest is in white, you know, white, blue, and blue, white. So I would say probability of you know, white, black, plus the probability of black and white, like that. Okay, great. I can substitute. My white is 6 out of 10. Okay, I'm going across. Remember, this is white, blue. I'm supposed to multiply like that. Okay, this is you know, 4 out of 9, like that, plus what else? I have this is black, which is 4 out of 10 multiplied by, okay, white, which is 6 out of 9, like that. Okay, remember you're supposed to use a calculator. 6 multiplied by 4 is 24. 10 by 9 is 90, plus this is 24 by 90. So 24 plus 24, okay, this is 8 out of 90. Okay, so if when you reach here, just a matter of you know, using a calculator, or you say you look for a number which can go into, you know, both 48 and 90 without leaving a remainder, which is basically their highest common factor. Or if you can't find their highest common factor, basically what you can do is you can start here reducing by, you look for the smallest number, okay, yes, which can be able to, you know, help you reduce this, you know, number. Yes, so the number here, you know, this is very simple. The number is 6. Okay, if I say 6 in 48, I should be able to get, you know, 8. 6 into 90, I should be able to get 15, and this can't be reduced, you know, any further. There's no number which can go into 18 as well as 15 without, you know, leaving a remainder. So hence their final answer is 8 out of what? 15. Yes. So thank you so very much for your attention.